Alright, so let's start our discussion where we left. Alright, so we were at this point. So one of the questions which we should, which keep on coming, whether HBase provides locking or not. So HBase only provides locking up to a row, meaning a transaction is guaranteed on a row. So updates on a row, as in adding values to a column family, different column family, or updating an existing value, or adding a fresh new column, all of these operations can be done in a single shot. Okay, without the intermediate states being visible to anybody. All right. Next is scanners. So to find out data in HBase, so to query HBase, we use scanners. Unlike a sophisticated query, HBase provides a very basic way of finding the data in the tables that can be done using scanner. Okay, so scanner is more like 3-4 parameters over which you could search in HBase. All right, now you can see that the the scanner is more like a cursor. Okay, they have to be closed after use. Scanner return rows in order. So you can provide a scan object as an argument. You could say result scanner as rs equals to htable.getScanner. It gives you the scanner over that particular scan area, where scan parameter, the scan parameter takes the following, it contains the following attribute. One, from which row can we start the scan? When I say which row, it does not mean row number, it means row ID. Okay, so you can specify that I'm looking for row ID from this point to this point, which columns to return. Okay, and a filter to run on the server side. Okay, you can also give a handle which can run on the server side. Yashwant's question is, CF has to be specified at the starting. CFs can't be altered later. CFs has to be specified in the beginning. But these days, HBase has provided a way to alter the column family. Okay, it allows you to add column family at later point of time as well. Okay, earlier it was not supported. Okay, you can try using hue for the same. All right, theoretically we should not be doing that, but using hue basically internally creates another table and then add one more column family and then transfers the data. Okay, although that's not supported by HBase. Alright, so once you get this scanner, the result scanner, it'll give you the number of rows, and every invocation of next would go back to another region server or the same region server. Okay, it will make a trip. Alright, so here is Java code which shows how to query the data using Java in HBase. And again, it is not some very sophisticated uh, queries, okay, because HBase does not provide a query to update or delete or insert data. Instead, it provides a very strong, robust, but primitive API. So you create a config object, and then so so first you create a config object, then you create an admin handle. Admin handle is the most important one, and then you define a table descriptor. Okay, then you define a column descriptor. You add this column family as the column descriptor and column family. You can add column family here, std dot column family. Okay, and once that is done, you can say admin please create table. Okay, admin dot create table, and here we are providing the table descriptor contains test as the table name and data as the column family. And once that is done, now we can start querying it. Okay, all right, so how do you query it is, okay, so the way, all right, to query an existing table, you could always use list table command, and you get a list of tables. All right, in case, okay, in case the table length is not equal to 1 and bytes not equal to this, it gives an error. Basically, we are here checking whether a particular table, the one which we created, is there or not. Okay, and so on. And the other important part to know is to insert the data. So let's say we have a table, whatever we have created above. Okay, we have a table, and we could create a binary object called put by passing an argument of bytes. Okay, and then similarly we can create bytes object for the value, and then insert that into the table. Okay, so you could see this particular line is more interesting. So here we are saying p1, which is a put. Okay, add these particular bytes, and which is the row id, and then okay, all right, and then this is the value. So we are specifying, okay, for this row we are inserting data into this particular column family, sorry, we are adding data, and then we are saying table dot put p1. Okay, so this way we can insert data into the table. All right, all right, so here is a few questions. All right, so here we are defining the row id. Okay, so this put is for this row id, this is the data. So we are adding p1, which is the row, and adding this data to this particular column, which is so column family is L, and some V1 is the column family name. Okay. All right. So exact API, I think there is something wrong with this API. Let me just take a look. Okay. So here you define the row offset, row length, and whether it's thread safe or not. Alright, let me just take a look at it. So we say p1 put.add. This is the data. Okay, put.add, and then we provide the cell. Okay, so we have row and row offset. Okay, and length of the data and this. Just a second. This is our data, then this is the offset, and then these are the values. Alright. This put should have a column family. Okay, put should have column family, and that's what I've been looking for. Ideally, it should be new put equals to where is my table, and we say table dot. Okay, so it should be like this. Alright, I'll take a look at it. I don't think this is complete. Okay, need to be looked into. Alright. Alright, so let me take a look at it at a later point of time instead of now, because what I believe see is that this put should have been created over over the table. Okay, specifically table, what do you call, table column. First we would create a table column, so column over the table inside a column family, and then we will insert data into it. Okay, so that's how it's going to be. and it looks like this is an old API. All right, so let me take a look at another time. All right, and the other important aspect with if you have to say execute a mapper reducer over HBase table, there are two ways to it. One, by using the existing mapper reducer and different input format. Okay, so there is a HBase input format which you can use, or you create an HBase table mapper. Okay, so how does it work is, so you write your mapper class, okay, which extends table mapper. Here you define only the output. Okay, the input is always the row. You always get the immutable row object. Okay, and all you have to do here is put the data in the context, and here you can define what is the output you are trying to give to your reducer. Okay, unlike our usual mapper where where there are four parameters at this point, here are only two parameters because first two are replaced by a single row. So you get a row in your map method is the full row, and you get a, okay, so you get, you can also, right, so you, all right, yeah. So whenever we have to query, okay, so all right, okay, there is one more question which I have not replied. Okay, so what kind of operation do you use MR in HBase? That's a question from Yashwant. Okay, so there are two situations. One is you want to use usual HBase input format, and this one. Why would we use MR over HBase? Because that's the best way to query, or that's the only way to query humongous data. Okay, so because this is going to run on the nodes where the data is stored, and query the data. When you have humongous data, and scanner is not sufficient. The scanner which we talked about is not sufficient in those cases. In those cases, you have to run the mapper reducer. Okay, scanner is very primitive. Scanner gives you only the access to the rows, and it does not let you uh, process the data on every individual node. It just gives you access to the row data. Okay, if you are looking to do a massive parallel processing of data, then you would use this. So Yashwant's question is, so HBase can't be used for online operation. It can be used for online operation, just that the MapReduce part of it can't be used. MapReduce can't be used for online processing. Okay, so if you have to do a lot of data churning, say grouping of the records and then saving the after grouping and all of that, that can't be done using in the real time. Okay, that anyway can't be done in real time by any way on a huge data. Okay, but it is used for real time and online transactions, online uh, data updation deletions across So you use HBase for the real-time work actually. Okay, except for the MapReduce. Except for a MapReduce, everything else can be used in real time. All right. All right. So you can see that we can write a mapper, and then similar to earlier, we could also write reducer, which extends the table reducer. And in this table reducer, you get all the values. You can see this is a column family name. This is the column name, and you can essentially whatever input is given by the mapper, you get that key and the values grouped together, and then you can write to the context. Okay, and what exactly is happening here? We are iterating over the values and summing them up. And once we have summed it up, we are creating a put. Okay, so we are creating a put for the key, whatever key we are given. Into this key, we are adding the column family. Okay, so actually, okay, so we are adding for this column family, we are putting the count for this column name. So this is our column name, this is the column family, and we are adding this value. Okay, so you can see this one is the data bytes is my column family. Okay, and yeah, it's the same column family which we have defined here, data and data here. This is the column family, and this is the column name, and this is the value. Okay, so this is okay. I got it now. This is correct. Okay, so this is my what to say column one, and this is the value one. This is the column family which we had defined. Okay, here, and it is the same column family here. All right. All right. All right. Let me. Okay, that's a question from Yashwant. Can you please explain the mapper again? Okay, let me try to explain it again. Good. Let me try to explain it again. All right. Great set of questions. Keep the questions coming. That's the only way to learn. Okay, let me try to explain the mapper again. So first of all, we are defining a class called myMapper. It's not necessary that you put a static here. Okay, it's not necessary that you define it as static, but static makes this class available only once. All right, although it's a kind of unnecessary optimization. So you can create mymapper and extend which extends table mapper. This is any name you create, and we are defining the output data type. Input data type is row. Okay, input data type is row. All right, and And the output data type is something we are defining here. So we are saying essentially that will be writing a map function which will get row ID, the row basically, and the value of the row. You can think of value as list of a, a big array containing column name and the value name. Okay, so we can just pass the column name. Column name is composed of, or you, column name is a composite of the actual column name and column family name. Okay, so we will from the value we can take out the value of each cell by providing the column family and the attribute. Okay, and whatever is our result, we can write it to the context. Okay, so here what we are doing is we are taking out text, okay, from the string, and then we are writing that into the output here, and that's it. Yes. So how many times it is going to get executed? That is the more important question. So for the whole table, for every row, our method called map is going to be called. For each row, if you have 1 million rows, then this map method will get called 1 million times. Okay? And this instance will be created per reason. Okay, the instance of my mapper will be created per reason, and that's how it's going to work. All right, and then similarly we have reducer, which will take the which basically defines the input data type, and okay, which takes the input data type like what is the input key, input value, and this is the output data type. Okay, so here we have key and the value. In the context, we are writing the put. Okay, here we are just passing the output, the row ID we are passing as null. Okay, and we are putting the value. Right. So that's pretty much for counting. Once you are done with writing the reducer, yes, the output is to another HBase table. Okay, so how do we stitch it together? Just the way we had step driver earlier, in the same way we can do the stitching of mappers. So you could simply say configuration config equals to hbase configuration dot create, and you have new job config. You can set the jar by class exactly in the same way we did earlier. Then we could optionally define a scan parameter. Okay, meaning we could pass the options, or we could limit the area of impact. Okay, so that is the scan parameter. And then we could say table reduce mapper util dot init table mapper job, meaning initialize my mapper job. Here is my source table, here is the area or the scan, and here is my mapper class which contains the logic of mapper. And okay, these are the output data type of the mapper, both of these, and here we are passing a job argument. So this is going to set the mapper in the job, and this is going to set the mapper reducer in the job. And once that is done, we could okay, we could define how many number of reduced tasks we want, and similar to earlier we would wait on the job for the completion. The moment we say wait for completion, then the whole process of running mapper reducer would start. Okay, and in case it did not return true, that means it has failed, and we are saying throw this error in case it failed. Okay, so this way we could create a table reducer. All right, this way we could create MapReduce over the HBase tables. Okay, once compiled, we could simply run it with the with the HBase command line, and it should execute. Okay, a question from Yashwant is, are there index on the columns? No. So the way we look at the index, how should I describe? So what do we mean by indexes on a column? Indexes on a column is not available, uh, unlike our usual RDBMS, where you could look up by any column parameter. Here, that's not possible. Okay, here that's not possible. So the primary component to look for is the row ID, row key, and then the rest of it. All right. Although you could say, give me all the rows for this particular column, that's also fine. Okay. Okay. Yeshwant's question is, also data insertion in one column at a time? No. You can you can insert multiple values, okay, in a input, and then add those puts. Okay. All right. You can you can batch many modifications to a row. All right. So yes, that's how it goes. All right. So that's the mapper reducer. All right. There is a question which is hanging for quite some time now. Let me answer that one also. In case of RDBMS, whenever there is a change in the structure of underlying DB, the applications that work on these DB need to be recompiled. In case of HBase, columns are created on the fly. How is the application program impacted by this? Okay, so that's a interesting question. So whenever we change the table structure of an underlying database, the application, so the code has to be anyway changed. So imagine that in case of HBase, we had a table and you change the table name. In that case, you of course have to change the code. Similarly, in case you're in case you have changed the existing table's column name, what would happen is the newer values which are getting inserted into the older table, they will run successfully, but into the different column. Okay, so you have to be yourself aware of it. So if you are changing column names, it won't fail your code. Nothing will fail. It'll happily insert into a new column or create the new columns on the fly. Okay, so you don't have to change the underlying the code in case you're just renaming a couple of columns. Okay, so you have to be aware and you have to be cautious. Yes, if the column does not exist, it gets created. Okay. It's like putting data in a hash table where if the value column, the key already exists, it overwrites the value. If key does not exist, it creates the key. Okay, exactly in the same way the whole semantics is stitched around. Okay, all right. So the other interesting aspect I want to discuss is, although we are not going to use Bloom filter in practice, because Bloom filter is by default defined and you're not going to intervene with the Bloom filter, but I want to discuss it because that's something people ask a lot during interviews. Okay, so I want to make sure that you understand the idea of Bloom filter. Bloom filter is a general concept. It's a data structure, or it's a algorithmic technique, you can say, to make the things faster in lots of cases. All right, and Bloom filter as a concept helps making things really fast. So let's discuss a bit about Bloom filter. All right, imagine there were single filter on your table. All right, and or let me try to describe it using some other means. Okay, okay, so imagine that there was this watchman, you can say. He was uh, let me see if I can draw something. Okay, so all the okay, let me try to explain what does it mean by Bloom filter. So there was this watchman. All the users are coming to him. He's looking up. He's looking up in the register. He has got a big register in which there are names of all the people, and it keeps on looking into this register. Okay, so users are coming to the watchman, and he's looking up in the register their names, and then he's finding it. So what's happening is there's always so many users waiting for him. Okay, so what he suggests is that let there be two people. Okay, let there be two watchmen. Okay, the one with okay, so let there be two watchmen, one containing a smaller list, other containing bigger list. Okay, okay. So this one contains, say, here it contains the only first two letters of each name. And okay, so again, the purpose of this guy was to find out the name of the people who are coming in the list, and in case they're existing in the list, he would let them go or he would just approve them. Okay, now he realized that he was overloaded with the work. There was too many people already waiting. So one more, he brought in his brother also, who is now doing the preliminary filtering. Okay, and how are we doing preliminary filtering? He designs a scheme that we will just give. So his brother, who is sitting here, he will have only first two letters from each name. Okay, which means there would be hardly 26 into 26 items in the list through which he has to scan. So his work, the first guy's work, has become really, really fast. Okay, in case somebody's name matches here, only then it goes for the qualification round. Okay, so the searching in the DB or searching has become in two parts. One, preliminary round. okay, and then the actual round. In case somebody qualifies for preliminary round, only then they go for the actual round. All right, and this is hashing technique. Instead of the way we did here was we picked up the first two letters, but there could be many more interesting ways to create a smaller list. There are many more interesting ways to create the first round of qualification, okay, first preliminary round. So there could be many ways. Maybe you just sum up the letters of all the names and divide them by, say, compute the remainder by 500, and then that's it. Okay, so those kind of things could be done so that the work of the first person becomes extremely fast. Now, this first person would be able to concretely say that that you are not allowed, but he cannot concretely say that you are allowed. Okay, why? Because two persons can have the same first two letters, or two person could have same hash code. Okay, so the idea of Bloom filter is to prepare a preliminary round with which you could concretely say that, hey, you are not allowed, but you cannot say concretely that you are allowed. Okay, so that's a preliminary round, because to be for preliminary round to be very precise is not possible. Only it can be precise in terms of saying no. Okay, because two names could have the same hash code, or two names could have same first two letters. Okay, therefore this first guy, the preliminary round, is called the, he's called the, what do you call, the Bloom filter. Okay, so Bloom filter filters only, uh, quickly removes those which are definitely not in the output. Okay, but it lets go some of the requests which have the same hash code. Okay, so for example, let's say in the actual list it is Sandeep, and only sa is given to this person, the first Bloom filter. Now, in case somebody called Sanjeev's come along, Bloom filter will say, okay, I'll let you go, but your actual examination will be done the actual actual search. Okay, all right. Do I make sense to you? Is this idea of Bloom filter clear to you? All right. No. Bloom filter is this guy. His name is Bloom filter. Okay. This is the actual scan. All right. Let me try to give more bigger example. Let's say who we have in the class. Let's say Abhishek. Okay. And let's say Mithili and Biswa and Jeman. It's not this. Let me. Okay. Let's say Mahesh, Mamta, and Abhay. Okay. Uh, Let me try to make it. Mahesh, Mamta, and Abhay. All right. So let's say these are the list of people in the. Okay. Let's just keep it list. Okay. So this is the actual list. This is the actual list, and this actual list is going to, let's say, tomorrow there are, say, the list goes up to 1 million, or say 1 billion records. Now, had the request been coming to this guy, the final guy, he would be really really busy. Therefore, he said that let's just create a Bloom filter. Let's just pick up the first two letters of each name, or maybe some hash code, and put it here. Okay. So you can see first letters, you have MI, MY, BI, and MA and AB. Now you can see that in this small list itself, we eliminated one more. Okay. So when the list grows really big, okay. So this is the list. This is the list of hash code, you can say. And this user, whenever somebody is coming, let's say this person, the first one, is coming, and he's asking, he's telling his name as Abhinav. Okay. So Abhinav, the first two letters it matches. Therefore, um, therefore, he let it go. Okay, he let go here, and the response of this user to Abhinav would be negative. Okay. Okay. So the all right. Then let's say the actual user, say Mamta, is here, and then in case of Mamta it says that okay, Mamta uh, is in the list, so it lets them go again. Let Mamta also go. Okay. And all right, so here the response of the server is this. Okay. This is the response of the final scan. Now let's say somebody like Sandeep comes here. Sandeep's essay is not matching in here, so this user, as in the Bloom filter itself, would deny. Bloom filter will itself say no here. Okay. Bloom filter itself would reject. Okay. Now question here is that what is the benefit of it? How does it make it faster? First, l- lots of people will be dropped in this category. Okay. Lots of people will be dropped at the Bloom filter label. Lots of search records which are definitely not there in the output will get dropped at this point. Okay. And only few will pass through till here. Okay, so you can see that in case of Abhinav, it was an unnecessary lookup. Once Bloomfitter looked up Abhinav, then the final round. So it was twice, while in case of Sandeep, he was rejected here itself. Okay, so here you can see that out of three total queries, there have been three plus two, total number of five queries. Had it been only Had it been only a single machine, there could have been only three queries. Okay, so on the prima facie, it looks like wastage of resources, but it is actually quite powerful because lots of false, lots of false records, which are lots of Unnecessary searches are avoided at this level itself. Okay. Okay. Also, Bloom filter does not need to hit the database. Bloom filter maintains the list of words here. Okay. Bloom filter maintains its list of words in the memory. So Yashwant, give you the answer? There are few more questions. Let me answer those questions. First question from Midley is who decides the filter? Okay. Generally, when you're designing the software, you will design the Bloom filter, and generally, the hash code is good. The hash code is good. So, this first question is Bloom filter is preliminary, a filter or both? It's actually preliminary. Okay. All right. That's right, Abhay. So Yashwant's point is that it is like a partial index but storing the actual value. Alright. So that is another example. Let me okay. We have an interesting question from Biswa. Question is it always two parts or there are some instances where more than two? Um, it is generally two part. Okay. Generally two part. I have not seen the case where with more than two parts. Okay, in case you are having more than two parts, you can actually tweak your Bloom filter. Okay, tweak the way you are creating this smaller list, either by hash code or by some other means. You could tweak this list. Okay, and you can get it done in a single path. I mean, instead of having multiple Bloom filters. Okay, will Bloom filter store partial values for all the columns or yes, it will only store the hash code. It will not keep the actual values. Okay? For actual, because if it keeps the actual values, then there would be no need to go to the main system. Okay? When Bloom filter would be able to decide. And the side effect would be that Bloom filter has to maintain all the values. So Bloom filter only have the hash code, or you can the say whatever scheme you design. Okay, Bloom filter will have the smaller set of data. Otherwise what would happen is the Bloom filter will still be same as the normal filter. Yes. So here the Bloom filter is on row ID. I'll talk about how it's related to HBase in a minute. All right, then I think your question will be answered at that point of time. All right, so this is how the Bloom filter works. All right. So again, the same depiction as earlier. So do you have a key one? Bloom filter has said no. In case Bloom filter says yes, then the main disk access happens. Main query to the main system happens, and if it says yes, then key 2 is here, otherwise it could reject here. So total number of lookups: 1, 2, 3, 4, 5. Total number of lookups are 5. There are 3 records. Okay, the total number of lookups are 5. But interesting part is that out of 3 requests, only 2 hit the main storage. So we were able to reduce the hitting of the main storage by one third. All right. Now, in case of HBase, you could enable Bloom filter per column family. Okay, meaning when the user is looking for row ID and the column filter, so column family name, it would quickly it would quickly look up in the Bloom filter, and then it check that whether the value exists or not. Okay, so Bloom filter can be enabled per column family. You can also, so by default, okay, you can also enable it for others. You could say, no, I don't need Bloom filter. You could say row as in the hash value of the row key will be added to the Bloom filter on every insert. So whenever there is a row created in actual table, the index or the small Bloom, we call it Bloom instead of saying index, the smaller list or the bloom will be updated with the hash code of the row. Okay, let's take it here. So every time the storage gets modified, the bloom filter gets updated. Every time we are adding one more name here, the first two letters will be updated into this bloom. Okay, so in case of row, this is what happens. If you say row column, the hash value of the row key plus column family combined with column family qualifier will be added on each key insert. Okay, so the criteria on which this list is generated, because a table has many columns, many rows, and etc. So there are only three modes possible. One, without the bloom filter. Second, this column is generated only after the row out of the row IDs. In this third fashion, this column or the hash code or this smaller list could be generated by a composition of row ID and all the column names along with the column family. Yes. So question from Midley is that isn't that double the work? What we are doing here is saving time or reducing the number of hits. We are so So on the prima facie here as well as here, it looks like that it's so much of work being done. But important part is the work got distributed. Some hit the filter and only few hit the actual storage. Okay. So lot of work get reduced because of this part. Okay. Because of this part. Essentially, the work of actual storage have got reduced drastically. Okay, because the storage is something which takes a lot of time. All right, yeah. All right, so that way. Okay, question from Abhay is, what about reconciliation between filter memory and actual storage? All right, that's what I was explaining. So every time something gets added into the storage, the filter gets updated. That's a very minor time, because how would it get inserted is the new record which is getting added into the storage. Okay, hash code of that one will be computed, and then it will be checked in this list whether that hash code exists or not. This lookup is extremely fast because it is from the memory. The only reason we have trimmed it down to very small is so that we can do all of this. We don't have to store this list, the bloom, into disk or anywhere. We can just keep it in the memory. Okay. So hash computation is quite quick. Second, looking up in the filter is quite quick, and also updating a filter is quite quick. Okay, so based on the storage, every time a record is getting added to the storage, we'll have to update the filter, and this updation is fairly fast. Okay, all right. Is Bloom idea of Bloom filter clear to everyone? No. Mahesh, Mamta, Medli, Abhay, Crazy, and Yashwant. Great. All right. So, in a sense, Bloom filter is a way of filtering the the negatives or the records which don't exist very quickly. Okay, by the way of establishing separate filter which contains only the hash code of the actual values, and this Bloom filter can concretely say no but cannot concretely say yes. Okay, in case it says yes, it would let the query go to the main storage and be looked up there. All right, the another idea for in HBase is coprocessor. It's little new but it's quite useful. Okay, so the way we have stored procedure in relational databases, similar to that, we have coprocessor in HBase. And what is a stored procedure? Stored procedure is something which runs on the server side. Okay. Similar to that, we have coprocessor. Coprocessors run on HBase region servers. The coprocessors can be executed on all the machines parallelly when something happens. Instead of a user query directly calling some method, here coprocessors automatically execute on every node in the background. Okay, so they behave more like a trigger than the stored procedure. So they are more like triggers every time you modify a table, every time you add a row key, or every time you update a column, delete a column. In all of those cases, this would be called. Okay, all right. Before moving to this, we have a question from Mamta. Can logical function be performed using Bloom filters? Logical function as in A greater than B or B greater than C kind of functions? The answer is no. Only equals operation can be performed. Right, because hash code, there is no relation between if there is an actual string, say Sandeep, and we want to say that is it greater than Sandeep Giri or lesser than Sandeep Giri, that's possible with the actual string, but hash code of Sandeep might be bigger than the hash code of Sandeep Giri. All right. Is that what you meant? So on hash codes, you generally cannot apply any logical operator like greater than, equal to, or something like that. All right. Okay, so with respect to coprocessors, which are generally like background triggers, so you can define your own coprocessors. It's a piece of code which stays on the reason server and gets activated when something happens. Okay, so for example, we have here an access control coprocessor. This access control coprocessor is the region server observer coprocessor. It's basically observing region. Okay, so whenever there is a request for get, this pre-get will be called. Okay, and and here it can intervene by by here. It can either it can either throw an error saying, hey, you are not allowed, okay, or can actually silently return the value. Okay, in this access control you could also put, pre-delete, and so on. Okay, so so you can define the coprocessor either in the post manner or pre manner. Okay, so using pre, you can control the access of various value. You can allow write or read of various values, and so on. Okay, by default it does not let the by default HBase does not come with a security layer, and that's where there are other security layers available. Okay. Okay. Biswa's question is it related to any specific table or it is generic? Okay. It is it is generic. So we basically can define this this coprocessor on a table saying whenever this table's row get modified, or we have a put operation, get operation, or delete operation, please execute this piece of logic. Okay. And how do you plug it in? There are two ways to it. One, you copy this piece of code, you create jar out of it, and copy this to all the machines, and then add the name of this into the HBase site config. Okay, this is the config where you will add the property name. Okay, or you could add it into the table attribute itself. You can programmatically modify a particular table, the one which you are trying to hook it with. You can define that table, and then you can say that for this coprocessor, please, for this table, please use this coprocessor. Okay, if you set an attribute called coprocessor $1, $2, $3, and so on, then that class is considered as coprocessor. All right. Also, you could add that class, you could load that path in from HDFS. First, you upload this jar into HDFS, create, and then you can specify this path into the HBase. Okay. So for each table, you can set an attribute saying that this is my coprocessor. You can see that we are mentioning that. So we for this particular table, okay, for this particular table, we are specifying for this particular column family, we are specifying that the coprocessor is this. Okay, if you do not specify column family and we set this attribute on the table, then this coprocessor will get executed for the whole table. Right now it's going to get executed only for this particular column family. Alright, you can take a look at the coprocessor package summary. Alright, next is that you can access the HBase from the alright, you can access the HBase from the URL itself, okay, by using the browser. Okay, that's the REST interface enable us to access any value from the browser or update any value from the browser. All you need to do is call the URL with get or post. Okay, get or put. Alright, so here is the general grammar. At the top level is the table and so on. And in the REST interface, when we talk about, the first thing is scheme, then the user and password, and then the port, and then the path, and then the values. Okay. So let me just change it. This is not done. So we'll have to start the REST interface first. And once we are done with starting the REST interface, then we can call it. Okay. So we can go to our server like here, and all right, so we could go to, all right, all right. So here we have, and we could basically the start HBase interface here. Let's try to run it. Okay, so it has kind of started the HBase interface. Now we can access this. All right, looks like it's not allowing. Let me try to start it at a different port. Let me try to run it at, say, 4041. Okay, because 4041 is something that we have allowed over our firewall. Alright, so you can see that we are able to access it is showing me the list of all the tables. So now we can say table 1, okay, the method not allowed. Next, what we can do is we can call my table and the row name. What is the row inside? Say row 1. Okay, we have to specify the column. All right, so we can go to the table details. Let me just say 12 December, and inside 12 December, what are the columns do we have? All right, we could just go to the console and find out. Describe 12 December, or scan, you could say scan 12 December. So these are the, it has row 1 and official details, column name. Okay, this is row 1 and official detail, and so we could say 12 December slash row 1 and official details. Okay, where is that? Yeah, so here we could say the column and column name. Okay, official detail is name. Remove this. Yeah, now you can see that it downloaded something here that contains the value. Okay, so that's what we have done. So using the URL we can do a lot of things. Okay, so this way we have launched our own HTTP service on a port called 4041 instead of the traditional one. We have started our own H-based service, and using this API download we are able to download or interact with HBase from the browser. Right now there is no authentication enabled, therefore we did not ask us for any login or password. So be aware that right now there is no authentication on HBase. That is why we are able to contact it. All right. So that was about. All right. I'm shutting down my service. So this way you can access HBase from the browser. Okay, you can look at the Stargate, which is the actual service which runs when in this manner. Okay, for the REST interface. All right, in case you are looking for a JDBC kind of interface, take a look at phoenix.apache.org. This one is the JDBC interface for HBase. It tries to resemble, there are quite a few nooks and corners that you need to tweak. You need to define a lot of table definitions, but then once done, it becomes very streamlined to query the table. All right, so you can run, it's a mostly like a SQL interface. All right, so that was a walkthrough of HBase. All right, and so we would like to start with Zookeeper. All right, any questions at this point? Biswa, Mamta, Abhay, Methili, Yashwant, Rezi, Mahesh. All right, so that was our HBase, and you must give it a try. There is a question, there is a problem statement in the LMS for this for HBase. The statement is the problem statement is that, yeah, where is that? Okay, all right. So in here you will get the HBase question. It's a subjective question. Question is, if you have to design a simple Gmail like email storage and you have to store data in HBase, what will be the tables? Okay, the way we had discussed the Google searches corpus. Okay, the way it had defined the row key. In the same way, you have to define what will be the row key and what will be the column family, what will be the column name. All right, so that's the question. All right, so take a look at this. All right, good, good. Yeshwant's question is, can we specify multiple columns in HBase? Yes, of course, because you get the whole row. So whatever you want to pick from the from that, you can do it. Okay, you get the access to the whole row. And while defining the scan parameter in the MR, in the table mapper, you could define the area, as in you can select the columns. All right. Okay. All right. So although we have been talking about Zookeeper for quite some time, but let's get into the details of Zookeeper. All right, here before we start, here is a question for all of you. Okay, imagine that imagine that you're writing a processor for emails. Okay, let's say you are writing something like an inbox search engine for all the users. So So you have written something called email processor. This email processor runs on every email in an inbox. Okay. So what you want to do is you want to run this email processor on all the on on multiple machines. Instead of running email processor only on one machine, you want to run email processor on multiple machines. Now this email processor reads the email and generates some keywords and prepares the index. That's what email processor does. Now this inbox is read only. Email processor cannot modify this inbox. So how would you avoid these email processors intervening with each other? Okay. How would you avoid one email being processed by multiple email processors at the same time? How would you avoid email processors, what do you call, trying to do the same thing at the same time? Okay. So, see, one question I have portrayed it in three different words. So, what is it that you will do so that these email processors, which are running on different machines, do not process the same email? They do not do the duplicate work. Anybody? Yashwant, Mamta, Abhay, Prezi, Mahesh, Mithili, Vishwa. Abhay is saying, since the email database across slice the email database across email processors. Okay, on what basis do you do that? So these email processors, so you are only allowed to write code in email processors. Okay, so if we say slice, does it mean that there has to be some master email processor who will read the whole inbox and divide? That's not something you have luxury. You only have written this piece of code called email processor. You want to run this, and all it does is it talks to inbox of this thing, reads the email. It can either skip a particular email or read a particular email and process it. Which by saying partition the email by sender email address like this. Okay. So please keep in mind that whatever logic you write in email processor, it will be symmetric across all the nodes. Okay. Because your approach is assuming there is some master email processor whose duty is to divide the work amongst email processors. Midley is saying that we can keep log kind of thing. Good. Okay, so Midley's point is that we can avoid reading the same if it is done already. So as I was telling you that as you are reading the inbox, you're not allowed to modify anything, not even marking it as read. Okay, so inbox does not get changed because of you. So this was saying email processor 1 will read emails starting with email address A and so on. Okay. So that does that mean that there will be 26 email processors? It's a single inbox, Yashwant. So the inbox might have spread over multiple machines, but the view it's giving to you is a singular. Okay. Okay. Mamta is saying that can we use timestamp? Yes, we can use timestamp. Yes. Abhay is saying next one would pick up the one which is marked for. Okay. Mahesh is saying they distribute emails in round robin fashion between processors. So that essentially means that there is somebody who you have the luxury of reading the whole inbox and then dividing the work. Okay. Prezi is saying that email processors are cluster aware. They can communicate to each other that which inbox from which to read. Okay. Biswa is saying we can keep a separate list which would read right outside the inbox and be updated by email processors. Yes, that is one good way. Okay, so Yashwant saying the email process is a mapper which will read what is available in its machine. Yes, so if we are using MapReduce for this. Okay, the question is even if we are using MapReduce, so whatever logic you write in the mapper, it has to it it has to be agnostic. The good part about mapper and all is that MapReduce has the luxury, but in case of MapReduce, the framework divides the work amongst you. Here that's not happening. Framework is not really dividing the work amongst you. Okay, the same logic, whatever you are running in email processor is running on all the machines parallelly. All right. brilliant answers. All right. So yes. So I would go with Biswa's approach. Although the answers you have given are brilliant, and they are used in different scenarios. Okay, in, in a similar scenario, but with minor tweaks. For example, if we have the luxury of having something called master processor and then dividing the work to others, then there is one approach which I think you have already mentioned. Then the second approach could be that the inbox is something which we can modify or update. Okay, so this technique, which uh, I think Mamta or Midli, somebody has said that mark the email as read. That's what one of the approaches which I had used earlier, and it worked pretty well. All right, but in this case, the inbox is read only. So idea is that have a separate database. Have a separate database that whenever an email processor starts processing, it puts that value in that separate database. And before it starts processing, it first checks whether it's there or not. If it is there, then don't use it. Otherwise, okay. So this email processor, okay, this email processor, as soon as it starts, so it picks up an email, checks if somebody has already processed it or somebody is processing it. Okay, if nobody has processed it, nobody's processing it, then it picks up the email and then starts working on that. Okay, and so on. So basically we are using a secondary database in this case, and and this is called a database that is required for coordination. Okay, all we are looking for an external source, kind of a flag post. It's a kind of a flag post on which everybody is looking. Okay, so we use these kind of flag posts or these kind of centralized coordination agencies in order to coordinate between various distributed systems. In case of single machine, the coordination is very easy amongst threads. Okay, single machine, same process, you can use threads for coordination. Every thread provide you the locking mechanism. Okay, but even the moment you have multiple processes, the thread locks and thread synchronization are totally useless. Okay, and again, in those cases, if you are trying to have the coordination between multiple processes, you will use the interprocess communication such as pipes or such as file system. Okay, but if you have multiple machines, then you cannot use files. In that case, you have to have a central agency. Maybe the central agency could be HDFS, MySQL, or any other database, a central database available through the network. But the problem with that is it has to be extremely fast. It has to be really fast, and that's where the zookeeper comes into play. All right, that's where zookeeper comes into play. So let's take a break and come back and take the discussion further. Okay, break for 10 minutes. Back by 8:46 a.m. IST. All right. So, all right. So, are you able to hear me? Should we start now? All right. Can we start now? Are you able to hear me? Yashwant, Vishwa, Prezi, Abhay, Mahesh, Mamta, Midili. All right. So, okay. So only Biswa and Yashwant is back. All right. So, I'm just waiting for. Are you guys back? Should we start now? Mm, only Biswa and Yashwant is back. What about others? Mahesh is also back. Okay. Yes. All right. Let's start then. We are already 2 minutes past. Good. So before the break, we talked about how the coordination between the processors requires a central agency, right? And the central agency could be anything. But when the demand for such central agency grows really high, okay, most of the existing systems do not scale well. And most of the existing systems are not fault tolerant. In case this central agency goes down, what happens then? So in all these scenarios, Zookeeper really works well. And there are few more use cases of Zookeeper. Few more use cases of Zookeeper is our discovery. Okay. For example, HBase master had to discover HBase region servers, right? So in that case, the discovery was happening by the way of Zookeeper. All right, we will talk about all of these details and we'll show you how you can use Zookeeper to build your own service. Okay, so Zookeeper is a distributed coordination service for distributed application. So it's a distributed coordination service for distributed application. What does it mean? First, it allows coordination between these services which are heavily distributed. If they are running on 10 million nodes, sorry, not 10 million nodes, they are running on 10,000 nodes, that also is fairly acceptable. So all these 10, there are, on one hand, there are 1 million users who are trying to discover a service, okay, which is distributed over 10,000 nodes. All of this coordination is very much possible by Zookeeper, and Zookeeper itself is distributed. So by studying Zookeeper, we will learn two, three things. First, we will understand what are the primitives required for coordination. Second, we will also understand how does a true distribution system work. Because right now, when we talked about HBase, we talked about NameNode, we talked about Yarn, all of these had a concept of master slave, which is designated by us. What if the biggest question which we faced in case of name node was what if the name node goes down, right? So that was not really highly available or truly distributed. Okay, zookeeper is one such thing which is truly distributed. So we learn all of those aspects, and we learn also couple of ideas from Paxos algorithm, which this is a very interesting topic for anybody who is into distributed computing. So stay tuned and pay real attention, because this is zookeeper gives us great chance to learn distributed computing, because zookeeper does not provide too much of complexity over the querying, this that. It basically provides a very simple primitives. So while on one hand it's extremely simple, on the other hand it does a lot of distributed computing. All right, so it exposes a set of primitives which are very easy to program to, uses a data model like a directory structure. Okay, so for coordination you could have used a centralized networked file system, right? And the whole idea comes from there. Let this storage be like a file system, be like look like a file system, or being very true, uh, this file system is more like a tree structure. Tree structure, okay, is like a big tree in which various people are writing their names and reading their names from, okay, or reading their data, writing their data too. Now it is used for synchronization and configuration maintenance. Okay, this is a coordination service. This is a synchronization or coordination service that does not suffer from race conditions or deadlock. It has internally resolved all those issues. It itself does not have race condition and deadlocks. Race condition means two two systems trying to compete with each other, and deadlocks means two um, two or more than two systems having dependency on each other, having a circular dependency. Okay, that's a deadlock. All right, to install, if you want to try it locally you can try it, but you don't really need it. You can download the releases and install it, and that's it. Although you can just log in into Zookeeper client and start using it from there. Okay, all right, so the data model of this will look like, okay, this. Okay, so the data model of Zookeeper is generally a tree kind of a structure. At every node in this tree you can store data, and every node can have children, and the children can again have data and have further children, and so on. Okay, and the way the tree is represented is by the way of separating by slashes. The top level node is slash, which is the root node, and under which you can define your own nodes, like slash zoo is a children of slash, and slash zoo slash duck is a child of slash zoo. Okay, so so Znode can have children, Znode can have data, Znode form a hierarchical namespace, Znode has ACL, okay, access control list. All right, so the data access is read write, is atomic, either full or, okay. So when you try to access the data from any, so you write your name, you can think of a big tree which has provided you all kinds of leaf, and leaf can have further leaves and so on. And you can write names everywhere. You can write your data here, 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 here. Everywhere you can write the data. But the condition is you can only just remove the existing name and put a new name. You cannot update the name. Okay, either the update would happen or there'll be an error. There'll be no partial updation. Those are the things which data model guarantees. All right, so inside the data model, which is a tree structure, there are different kinds of things. Okay, each node is also known as Z node, as in zookeeper node. And this zookeeper node can be of different type. The first and the default one is persistent type, meaning it will remain there. Okay, remain there unless you manually delete a particular node. Okay, these are the classic Z nodes. Okay, so a Z node in case of zookeeper remains there unless you delete it. So you can use a command like create slash my node and my data. I think a better thing would be, instead of talking in air, let's try to do it right away. Okay, let's try to do the demo right away so that you will all be in the perspective and you will be able to. So this is our zookeeper. Okay, you can say ls, you can say ls slash. You can see there are so many nodes here. So right now we are logged in to Zookeeper. It provides ls command similar to normal file structure. Using ls command, you can list all the children of a node. So here we are saying ls slash, meaning we need children of slash. And these are the children starting from registry till config. These are the children of Zookeeper. Okay. Right now there is one particular node. Okay, so all you need to do is after you log in into the console, so please log in into the console and you can start Zookeeper Desk Client. Okay, if one of you is able to do it, we will able to coordinate between me and you using the Zookeeper itself. Okay, all right. So let's keep it this way. Okay, so here you can see there are these many nodes. Now we can create our own node. I could create slash 12 December with some data called initial data. Okay, so this is okay. Okay, so it has created the initial data. It wants it to be separated by space. That's little, yeah. So it already exists. Now you can see that. All right. Now, if you want to create a children of this one, you can create a children of, we could say slash 12 December slash student 1. Okay. Uh, uh, uh. So we could say, all right. So you can see ls slash 12 December. You can see there is a student 1, and you could say 12 December slash student 1, and you can see the detail about this. So this is a typical name. The name of the node is slash 12 initial data. No. The second string what we have put here, the Yash for example, is the data, and this is the name. This is the name of the node, okay, and this is the data which we provided. The second string which we provided was the value of the node. All right, is everybody with me? So we just created a first top level node called 12 December, and under which we created student or okay. So you can see that on 12 December also we provided initial as the value. Okay. Yes, everybody with me? Good, good. So essentially we can use ls, get, and create as the basic commands. ls gives list of nodes or z nodes, and get the data of a particular z node, and put gives us the ability to put the data, or create gives us the ability to create a particular z node. Okay, for creating the z node you need to specify the parent url followed by its own URL. So if you are creating top level, you have to specify slash, which is the parent, and then this current node's name. Okay, is everybody with me? Should we start with further discussion? No, initial is not the name for the data. No, initial was just some data. Okay, or like for example, we could go here and create another node. We could create another node. Okay, we could create student2 with the name, with the data containing Mithile's data. Okay, like this. I don't know why it doesn't accept my, does it accept this way? It wants, it doesn't accept Mithi. Okay, oh, somebody has already created student2. Okay, we could say, okay, student2 is the data. What is the role of data? That is the actual data we are putting it. One is, you can think of, this is the file name and this is the data inside that file. Okay, so there is a node, and node is carrying the value. Node is represented by the path and the value is there. Okay, so everybody with me in this? Now, the very important aspect of Zookeeper is ephemeral node. The ephemeral nodes are the nodes which disappear when the client disconnect. Okay, for example, let's say I'm creating an ephemeral node using this technique. Okay, I'm saying here, after going here, how did I disconnect? Okay, never mind. So I go here and create an ephemeral node. Okay, and let's say ephemeral nodes are the z node which will disappear as soon as I disconnect. So I'm saying slash 12 December my EPH. Okay, okay, let's say I'm writing its name as what do you say, some data. Okay, so right now it exists here. You can see that my EPH is existing. Now I exit from here. Now wait for 2 seconds. Wait for 2 seconds. Since the client has disconnected, what would happen is it will make my node disappear. Okay, so let me see. Right now it exists. In a minute or two, in a few seconds, it will disappear from here. What does it mean, and why do we need it ephemeral? Okay, so ephemeral nodes are the ones which are deleted by Zookeeper as soon as session timeout. It cannot have children because otherwise children will have to be deleted. So an ephemeral node, okay, cannot have children, not even if the children are ephemeral. Okay, now you can see that my EPH has disappeared or has been deleted automatically. Okay, because I had disconnected the session. Although the ephemeral node does not mean that these are only visible to me, it would be visible to everyone. Okay, okay. So for example, this will create a node under my node with this name. Okay, so this is the second kind of ephemeral node. Sorry, these are the second kind of Z node called ephemeral node. So Mamta's question is, since Zookeeper is used for job sync and configuration, why do we need data there? Okay, so uh, I mean, every node might require extra data, not only the node. Most of the communication could happen via the node, but sometimes you need one more parameter. It's like saying that why do we have key value pairs in a hash table when we can do everything with a key, right? Similarly, it provides you two places to put data. One is the key name, another is the value. Okay, so you can think of the path as the file name and the data as the content of the file name, because not all communication would suffice via the file, the node name. Okay, all right. Now, next one is the sequential node. A lot of times when we are coordinating, a lot of times whenever we are coordinating between systems, we might have to generate IDs. For example, let's say you're building a help desk system, and these help desk systems, all of them is running on multiple machines. Since you realize that your help desk need to be kind of parallel, kind of distributed on multiple machines, you need a centralized way of generating unique ID in a sequential fashion. Then you go with kind of models like Zookeeper. So you could use Zookeeper's ability to generate a sequential number in at many places. So while creating a sequential node, you specify the prefix. Okay, if the prefix can be empty string. For example, here I'm saying that create minus s slash ju and v. It'll create a node with the prefix as zoo and the suffix as the currently running number. Every z node, every parent z node has a running number. Okay, so if there is a children of a particular node, that will have its own running number. Every time you create a node, this running number increases. Okay, so it's like count of the children, is the count of the children every node maintains. Every time you create a node, this number increases. Okay, so basically, it's a good way to have the sequential number generated. There could be multiple applications which are maintaining their own sequential number. So this sequential number is quite useful. Okay, this counter keep on increasing monotonically. All right. So you can see that if I create minus s and give the top slash ju, which means I'm trying to create a node, sequential node whose prefix is ju, and under slash is the top label parent. Okay, And in case I want to create a children of Jew, then what I will say is I'll provide empty string here. It means empty is the prefix, and then it'll create the rest of it. So, all right. So it's clear to everyone. So this counter keeps on increasing continuously or monotonically. Every node keeps a counter of the children. Okay, and when you try to create the children of a children, then the number again starts from zero. All right. So I hope everybody is clear about this. Now, these are the three kinds of nodes. One was persistent, second was ephemeral, and third one was sequential. Okay, third one was sequential. And all three have different use case scenario. Yes, go ahead, Biswa. Let's try. So if you see, if I create sequential node under this, I say Biswa as the prefix. Oh, I forgot to do. So I say create minus as 12 December and then say Biswa and some data. Okay, you can see that the number from which it has started is 003. Okay, if I create the the child of this particular node which has been generated sequentially with, let's say, grandchildren. Okay, it's a grandchildren, and I just write my name. Okay, so here you can see. Okay, I could create. Okay, so 12 December and then Biswa. Okay, you can see that the node that was created under Biswa is starting from zero. Okay, or similarly, if we are saying create minus as 12 December student 1, and I have just put, say, something like A, okay, and put some data inside it. So here you will see the number starts from 0. Okay, you can see that. Why did Biswa start from 3? The reason is already this particular node had created 3 nodes. 0, 0 was this one, 1 was this one, and the 2 was deleted by us, and third one is Biswa. That's the reason the suffix was 3. As I was telling you, it's basically count of total number of Z node created so far. Okay? It's a total of nodes that are created so far. All right. Now, with respect to the architecture, okay, this first question is under what node it will get created. Okay, if we say create minus as, let's say this. Okay, what will it do is, and some data. Okay, so it will create a node under slash. Okay, under slash. Okay, create under slash with empty prefix. Okay, if you say something like this, okay, what does it mean? Create under slash but with the prefix these. Okay, now if we say create under this, okay, or we say things like this. Okay, let me, so what will it do? Okay, it'll create under this slash x folder with y as prefix. Make sense to you now? Okay. Yes, Yashwant. Okay, great. So everybody clear about Z nodes. So this was the first part of Zookeeper. Using these basic semantics, you can continue to use Zookeeper in various circumstances. Okay, all right. Now that was the basic way of talking. Now let's talk about the architecture. There will be many questions that what if this particular zookeeper dies? What happens in this scenario, and so on. Now the architecture of zookeeper is probably the most interesting one out of all the things which we have studied so far. Okay, and it's basically the true distributed. Okay, so with respect to architecture, it runs in two modes, standalone and replicated. Standalone is not to be discussed, it's useless, it's only for testing, while replicated runs on a cluster of machines called ensemble. Okay, we call this cluster called ensemble, and there are many machines which are part of the ensemble. Okay, it's replicated meaning it's highly available. You will see how it's highly available, and it runs as long as there is a majority. This is something very interesting part. Okay, so let me explain. When you have these machines and you have put all of these things, so when you install Zookeeper, you just mention that these are the Zookeeper machines. Okay, on everywhere you run, you do not say this is a master, this is a slave. No, you just make all these machines part of the ensemble, and I mean you install the service, Zookeeper service, and then you make it run everywhere. We call them, all of these nodes are having Zookeeper server. Okay, all of these are having Zookeeper server. When the cluster is brought up, when you start the Zookeeper server on all of the machine informing about each other, okay, what happens is the leader selection happens. The beginning, it starts with the leader selection. The machines elect a distinguished member. All these machines run an election, they vote for each other based on the ping response time, and based on how many pings were successful and how much time it took. Based on that, they vote for each other. Okay, out of the interesting part about this election is everybody votes for everybody else, okay, including themselves. Okay, so based on number of votes received, they all unanimously agree upon a leader, and that particular node is marked as a leader, and everybody makes a note of it. Okay, everybody makes a note of that this guy is our leader right now. Okay, and that particular leader, the main responsibility of the leader is to serve, to write request when people want to change data, update data, delete data. In those cases they talk to the leader. If that kind of update request or change request comes to anybody else other than the leader, they redirect that request to the leader. Okay, so that there are no conflicts. Let the leader takes care of modification of the data. Okay, let the leader take care of the modification of the data. Okay, while the followers, the others are called followers, they give the read, they serve to the read request. If you want to read some data, you want to check what nodes are there, what is there in the data, then in all of those scenarios the request goes to the follower. Ls get goes to the follower, while put create goes to the leader. Okay, so and once the election has happened, leader, somebody has become leader, the followers will synchronize their state with the leader. The other criteria for somebody to become the leader is they should have latest version of every node. Okay, they should have the latest version of every node. So that sequence number that is being generated, that same sequence number is used to identify which node is the latest. Okay, all right. So if the leader fails at any point of time, within 200 milliseconds, leader is dethroned. Okay, and the election starts happening and somebody else becomes the leader. Okay, so the ping response time is around 200 milliseconds. If the majority is not available at any point of time, okay, if majority is not available at any point of time, okay, the leader would step down. Okay, so let me try this explain again. So the election chooses the leader, but election will not happen if the leader is functioning well, or the total number of people who showed up, the total number of people who showed up for election are 50% or 50% or less. If total number of nodes which configured in an ensemble were 10, but only 5 showed up for the election, then nobody will be the leader. There'll be no success in the in the election. There'll be effectively no conclusive election would happen, or election will not happen at all. Okay, because only few showed up for the election. Okay, so this is a very important part of election. At any point of time, the leader realizes that only 50% or less than 50% of the nodes are alive. Rest of the 50% or more than 50% nodes are dead. Leader automatically will choose to step down from its position. Okay, at this moment it might sound very silly to you that why would leader step down if there are less number of nodes available than 50%. Okay, but you will understand why it is so. I'll go into that detail. Okay, Yeshwant, that was the last part. So the leader will step down in case something is wrong. Okay, something could be wrong as if 50% or less than 50% are the only nodes that are alive right now, rest are dead. In that case, the leader will step down and there will be no election. Nobody becomes a leader. Okay. Also, as soon as the leader is selected, the nodes synchronize their state with the leader. Okay, that is the replication, Yashwant. All right. So all the write request, whatever requests are coming for changing modification, they are forwarded to the leader. Leader broadcasts the update to all the followers. And when a majority has saved, persisted the change, leader commits the update. The client's gets success response. The protocol for achieving consensus is atomic. It's like two-phase commits. Yes. So the most important part to remember, Yashwant, as you are very right, that the information, whatever data you have in Zookeeper, is available on all the nodes. On all the nodes. If you have 100 nodes and you are having 200 MB data, you are effectively consuming around 20 gigabyte. 200 MB and 100 nodes. Okay, so it'll consume around 20 GB storage because this 200 MB will go to all 100 nodes. Prezi's question is, if no leader at the point, how does the task distribution happen? Okay, so yeah, in case there is no leader at any point, reading will keep on happening, but writing will not happen. You can't change the data. Okay, all right. Also, every machine writes to the disk before the in memory. All right. Now here is another. So let me repeat. So every write request, whenever there is a change or modification request, it is redirected by all the followers to the leader. Okay. The will leader will take the change, write it to the disk, and at the same time it will inform all the other nodes, and all these other nodes followers will start writing also. And as soon as majority, okay, 50%, more than 50% has saved the data, only then leader gives a confirmation to the request saying, hey, we have got 50% majority confirmation, and hence your data is safe with us. Okay, and hence your data is safe with us. This majority aspect you will understand at a later point of time. Okay, so Prezi's question is, what is the advantage of having same data in every node? Is it not data redundancy? So since zookeeper is zookeeper is highly available coordination service, that means that this data has to be made available on all the nodes for extremely fast response, as well as extremely for the extremely dire situations where so many nodes are already down. Okay, although it is at the cost of data, but that's what differentiates that's what differentiate zookeeper as a coordination service, because when it says coordination, and as Mamta was also saying earlier, then what's the need of data when we already have a path, right? Because coordination doesn't need to contain so much of data, right? Coordination can happen by the way of very small bits of information. Okay, the most important part of the coordination is the central system has to be available and has to be correct. Only then only then it can act like a coordination service. Mahesh is saying, what is the criteria of winning an election? There are effectively three criteria. First, how fast did a server respond to a particular ping request or heartbeat? Second, how many ping requests failed? Third, what state of data do you have? Okay, so out of all the nodes, the node containing the fresh data, the data with the timestamp, the latest timestamp, okay, that will win the election. Okay, a common question which a lot of people ask me, and it has taken me some time to figure it out by going through Paxos, and this will be the most simple example, most simple explanation. Okay, so let's talk about a bit about election. If you have three nodes A, B, and C, with A as the leader, and A dies, will someone become leader? Yes or no? Two out of three is majority or minority. So after, so there were three nodes A, B, and C. A was the leader. A is dead. Now, will B or C become the leader. Right now, 2 out of 3 nodes are alive, which means 2 is greater than 50%. 50% of 3 is 1.5 and 2 is greater than 1.5. So majority is there. So will there be election? Mahesh says yes. Biswa says B votes for B and C votes for B and C. That's correct. Yes. So there will be an election. Either B or C will become the leader. All right. All right. Now you had three nodes A, B, and C. Okay. And A and B die. Will still the C will be the leader. You have three nodes A, B, and C with C as the leader, and A and B disconnect, or A and B stop responding. So what will happen? Will C remain the leader or will it step down? Yes, yes, Mamta, you are right. No majority is available at this point. So it will step down. That's right, Prezi and Yashwant. Brilliant, brilliant. So in these circumstances, C will step down from its position. Okay, and nobody will remain the leader. Now, you might be wondering why is it so? Why is it so that at least I have some machines up and running? It should cater to some users, right? Why didn't it remain the leader? It's like a big loss to us. Imagine you had 100 nodes and only 50 are dead. And still, even if we have 50 nodes up and running and still there's no leader, the whole cluster has become read only. Do you find it to be reasonable? Don't you find it's like wasting of resources? We have already 50 machines out of 100 and still the whole cluster is read only. Don't you think it's so much of wastage of resources? Do you think, is it right? Yes. So can anybody give me a reasoning why? I have given you a hint by showing this slide that even though we have 50 machines out of 100 running fine, still the whole cluster is read only. Don't you think it's very unreasonable? If not, then what will be the reasoning behind such a behavior? Yes? Anyone? Okay, yes, there won't be consistency, but how? I want to understand exactly how. Yes, anyone? It has taken me some time to figure it out. Okay. Vishwa, Mahesh, Mamta, Midli, Prezi, and Yashwant. Yes. Great. So Mamta says that there won't be any consistency, and in case there is no link between data center 1 and data center 2. Brilliant. Brilliant. This is why saying most of the dead servers will have few complete files replicated, so won't be able to write. All right. Most of the dead servers will have few completed files replicated. Okay, okay. So may not be able to write. That's also a very good answer. Okay. So okay, I'll come back to Biswa's point after this discussion. That's a very important point. Okay. Brilliant. Great. So yes, let me try to explain it. Okay. So imagine, so the point here we are trying to figure out is why is this 50% vote? Okay. let's take the votes of all the people available and elect the leader. Okay, what if that was the case? What if we would not care about how many people showed up for voting? We would just elect based on the number of votes available, right? What is wrong with that? Okay, Mahesh's answer is replication of data when link server come up will generate a lot of traffic. Okay, all right. So imagine that we had these six machines, A, B, C, and D. Out of this, A is the leader, and these six machines are existing over the cluster. Okay, three in one data center and other three are in another data center, or you can say that first three are in one rack, other three are in another rack, and they're connected. Oh, these two routers are connected. Okay, out of these six machines which are in network, A has been chosen as the leader. Let us say that the wire is disconnected. Okay, the wire is disconnected, and let's say this particular cluster does not obey this particular cluster does not obey the majority of rules. Okay, so what will happen in this case is the second cluster, realizing that they don't have a leader, they will elect somebody as the leader. Okay, if they don't follow the majority, they will end up having two leaders in a single cluster. Okay, so if you see single cluster, two leaders, some writers are going to A, some writers are going to D. D is the second leader. So effectively, we will be in a state where there will not be an eventually consistent. The system will never be eventually consistent because A and D are leading to totally different states, right? A created some data, D deleted some data, and so on. That is happening continuously, and there is no consistency. A user goes to A, he gets a different results. User goes to D, it gets different. So it becomes like two separate ocean of data which have nothing to do with each other. They used to have same data, but no longer the data is same. So effectively, the whole data is corrupted, leading to chaos. This by saying why not checking the concentration of that server? Okay, how would you check the concentration of that server? When you are when you're defining a network topology, it's not possible to figure out how are we disconnected. Okay, from network topology, there could be many different cases to to observe. Okay, and it is a very intricate task to figure out exactly what topology has been lost. Okay, all right, so is this clear to you that why do we need majority in the election? All right, now imagine now, had there been no majority rule here, then what would happen is the moment the two data centers, data center 1 and data center 2, are disconnected, A would step down. Okay, A would step down, and and there will be no leader in data center 1 and no leader in data center 2. All right, okay, Biswa's point is that let's say we have 70 servers in data center 1 and 30 servers in data center 2, and disconnected. Okay, but again, if we have 70 servers in data center 1 will have the leader while data center 2 will not have the leader. All right. So you can see that if you cut a piece of cake in such a way that it has two parts, and one part has to be, or let's say you cut a cake in such a way that one of the pieces has to be bigger than 50%, then no matter how many pieces you do with the other part, there cannot be any other piece bigger than this one. So the biggest piece of a cake is a majority. Okay, at any point of time, there can be only one such piece which is majority. That's what I'm saying. So majority can be only one single group out of any subgroups of any big set. Okay, so if you have a very big set or big cake, and I say that I want the largest piece of cake because it's my birthday, I want the largest piece of cake. The only way to ensure it is that I take more than 50%. If I take more than 50%, I will have the largest piece of cake. Nobody else will have the largest piece of cake. And and there will be only one such piece of cake. Okay. So majority is singular in case of any cluster, and it's therefore there will be only single leader based on majority, and effectively there will be no data corruption. All right. All right. The other thing which Biswa told earlier, that's also a very valid reason. Okay. Other reason from Biswa was that the nodes which are lost might be having the data from us. Okay, because we had said that when the majority syncs the data, only then a change is considered as a change. Okay, if the majority could not sync the data, the change is not considered as a change. Okay, so let's say there was this data saved by these servers from first 50 servers. Okay, first 50 servers have saved the change. Now, out of these first 50 servers, out of 100 servers, there are 51 servers which have saved the change, and hence we have confidently said that okay, this change is saved. What happens is, in case the same 51 servers are dead, then the change is lost. Okay, so that's another reason why there has to be majority in the election. All right. Now, quick question to all of you. An ensemble of 10 nodes can tolerate a shutdown of how many nodes? Quickly. That's right, Biswa. 4 nodes. Brilliant. Brilliant. Great. Thank you, Yashwant. Thank you, Mamta. Brilliant. All right. Now, the usual, the some more details about how do people connect to Zookeeper. So, Zookeeper maintains sessions. So whosoever want to talk to Zookeeper, it will maintain a list of servers in Ensemble. Okay, so the client has a list of servers in Ensemble. It tries to everyone until it's successful. Server creates a new session for each client. A session has a timeout period. It's decided by the caller. If the server has not received a request within the timeout period, it will expire the session. Okay, this, this way the client has to keep pinging the server saying, hey, I'm alive, don't delete my ephemeral nodes, don't consider me dead, I'm alive. So it has to continuously ping, so the client keeps on sending the heartbeat to the server, and that's how Zookeeper maintains the sessions. Okay, And on the session expire, ephemeral nodes are lost. To keep the session alive, client keeps on pinging all the time. Client library takes care of the heartbeat. So you as a developer or you as a programmer do not have to keep sending the heartbeat all the time. It's the client which keeps on sending that. Okay, client library's duty is to take care of all these nitty-gritties of the protocol and session maintenance. Okay, failover is handled by the automatically by the client. So initially when you connect to Zookeeper, you give it list of Zookeeper clients available, Zookeeper servers available, and it will keep on trying to connect all of them and also gather the list of the whole cluster from these existing client, and the client will maintain that list and will keep on pinging to all of those nodes and will gather the data. Okay, so this client, because it's maintaining the list of all the servers, can connect to any of the nodes. Okay, and in case the client tries to write the request, write the data, he will be redirected by the API to the node which is a leader. Okay, so application cannot remain agnostic to disconnection, because there will be there will be a time where client is not connected to the server and is trying to reconnect to somebody else. In that case, your operations might fail. All right, so the way, this is a status of Zookeeper. So you start as a Zookeeper instance, client starts trying to connect it, the state changes to connecting, then it keeps on waiting for the connection to happen, and then Zookeeper will send an event saying, hey, you are connected, and then the connection starts. All right, now let's try to understand the use case. How does it happen in coordination? How does Zookeeper help in coordination? Yesterday when we were talking about HBase and we started the HBase client, it showed us these many machines are dead. Why did it show? Okay, it had the old list of Zookeeper servers, old list of HBase regions in the Zookeeper, and that's the reason. I'll come back to that again. All right. So how does the coordination happen in case of using Zookeeper? Okay. Let's say you have this highly available service which is running parallelly, and same code is running on hundreds of servers. Okay. Say there are hundreds of servers and there are millions of clients. These millions of clients cannot keep track of which server is up, which server is down, and which one should we connect to. And that's why all these 100 servers are told about Zookeeper node. All these 100 servers create their ephemeral node inside a particular node. Okay, so as soon as any of the server is dead, the ephemeral node will disappear. All right, and this ephemeral node as the data contains the IP address of every server. When the client comes and client also talks to Zookeeper, and Zookeeper gives out that, hey, under this particular node, these are the nodes that are available, so you can pick any of these nodes and start connecting to that particular server, and the node name contains the IP address of the server. Okay, so the client does not need to talk to individual server, and client does not keep on pinging or keep on tracking which server is dead and which server is alive. So Zookeeper acts like an intermediary. It's like a big board on which keeps on getting washed all the time, and the student in the class have to keep writing their name, otherwise they will mark as not paying attention. Okay, so the way I keep on asking all of you continuously that, are you there? Are you there? Okay. Unless you say yes, I'll think that you are not there. Similarly, Zookeeper keeps on. If there is no heartbeat coming, it'll think that the user has disconnected and will delete their ephemeral nodes. Okay. So this is how the whole coordination system works. Now let's have a look at this one. So this is the server or the client. Both are the clients for the Zookeeper. Zookeeper is like a central agency. So first, the server comes to Zookeeper and says that I want to connect. Okay, once connection has been established, then the server says, can you create an ephemeral node called duck? Then another machine comes in and creates similar way called cow, okay, under the server list. Now the user client comes in and says, give me all the domain names of the servers under a z node called slash servers, and it gives the list of servers like duck comma cow. Now this client knows that, hey, any I can talk to any of these machines. Okay. After 5 seconds, another client comes in. By that time, duck server was killed. Duck server was killed, and after 5 seconds, this client has come in. Now, since the duck server has been killed, what would happen is the ephemeral node which was created for duck is dead. Okay. Ephemeral node has been deleted because the duck server has been dead. Now when the user says ls slash server, it is only cow left. Okay. As a real instance of the same thing, okay, as a real instance of the same thing, you can take a look here. You can take a look here, ls slash. So you can see there is hbase unsecure. So you can see, okay, the region servers, you can see here master region backup, and where was that replication running. Okay, so I'll say, so there are no, okay, it can't be there, table running. So all right, we have Zookeeper, hbase, rm, consumer, admin, main, accumulo, hive server 2, consumers. What is consumers? ls slash, it used to have my machines, ls slash hbase unsecure. I think this is the rs. Yeah, you can see that, it shows that the region servers are these two. Okay, in case one of them goes down, the list will disappear. Okay, you can say, okay, so you can see that this is the region server running at 16020 port. Okay, so in case anything goes wrong, this will disappear. Okay, and here it shows that there is an ephemeral owner, this one. Okay, this particular id is the ephemeral owner. Clear? All right, so the region servers and the hbase master both are talking to each other via Zookeeper. The region servers write their name in the Zookeeper. HBase master discovers its region servers by doing ls hbase unsecure slash rs. Okay, that way they talk to each other. All right. All right. All right. So the guarantees there are, okay. Other than so we talked about architecture. Let's talk about a little bit more about Zookeeper in detail. So there are many guarantees which Zookeeper provides, like sequential consistency, update from any particular client are applied in order, atomicity, either the change succeeds or fail. There is no intermediary stage. Single system image, a client will see the same view of the system. New server will not accept the connection unless it has caught up or synchronized its state from the leader. Durability, once an update has succeeded, it will persist. Per- Persisting does not mean memory, it means disk. Timeliness, rather than allow a client to see very stale data, the server will rather shut down. Okay, these are the various commands or operation which we have already used in in Zookeeper: create, delete, e- exist or ls, get ACL, set ACL for checking, putting the access control list, and get the children or do the ls, get the data or set the data, or synchronize the state with the Zookeeper. Okay, okay. Now, the interesting aspect about Zookeeper is that it allows you to batch many operations in single shot. Okay, either the whole batch succeeds or nothing succeeds. Okay, using batches, you can implement transactions. Others others never observe the inconsistent state, because that's the definition of Zookeeper. Every API of Zookeeper has two forms. One is synchronized, other is asynchronous. The core APIs are in Java and C, while the secondary APIs are available in other languages like Perl, Python, and Rest. Okay, so synchronous means that you wait for the result to appear. Asynchronous means you do not wait. Instead, there is a callback coming from the method. Okay, and Zookeeper provides you watches so that you can get notifications about the nodes. Okay, watchers are triggered only once. If you want to keep triggering again and again, you have to re-register in the trigger itself. Okay, all right. So watch triggers are many. Watches of exist are triggered when the node is created. So whenever you're calling exist, you can also pass in the trigger. And watches of exist are launched when the node is created, deleted, or something happens with the node. Okay, and the watches of get data are triggered when the node is something happens to the node, as in data is changed or deleted. The watches of get children is are triggered when the nodes are added into the children into a node. Children are added to the node and something happens to the children. Okay, so yeah, all right. So since Zookeeper is going to be organization wide, there has to be access control list, meaning multiple applications will be talking to Zookeeper. Right now, our Zookeeper is not secure. Okay, we only some part of it are secure. We are working on it, making it secure. Okay, the access control list is composed of three things. One is the authentication scheme, the identity of that scheme, and the set of permissions. All right, the authentication, it provides three kinds of authentication: either IP based, or Kerberos based, or login password based. All right, so we have already talked about the hands-on. There are many more use cases of Zookeeper. It's for building a reliable configuration service, a distributed log service, and only single process may hold the lock. Okay, so this is okay. So basically, Zookeeper can be used in many ways. All right. So when not to use Zookeeper? That's a very important question. Question is, although Zookeeper sounds like a great file system which is highly available and it provides you structure and it provides you access control list, but when not to use? Not to use when you want to store some big data. You use it when you want to store only tiny bits of information, because number of copies of the data is going to be equal to the number of nodes. If you have 100 nodes and you have 100 MB data, it will consume 10 gigabyte of storage. And when you require extremely strong consistency on the whole file system, because here it's eventual consistency. Okay, it's eventual consistency, because if you see, when the write has been done, when the data has been written, it will only go to 50 more than it will go to majority, not to all nodes. So if somebody is reading from the node which is still synchronizing, then they might receive a little older data. So extremely strong consistency is not supported even in Zookeeper. So our cap theorem still applies. It's an eventual consistency. All right. So that's pretty much about Zookeeper. I hope you like the session. All right. So do the hands-on. Try to create the node. Try to delete the node. Try to create ephemeral node, and after that, try to disconnect. So that will give you a clarity on Zookeeper. All right. That's pretty much. Thank you very much, and have a good day. Seshwan's question is, what scenario we use Zookeeper? Everywhere you either need to discover servers, there is a coordination required between machines, or where you want to just save the configuration, small configuration, not like huge configuration, but a small configuration. In those scenarios, you use Zookeeper. All right. Yes, MR framework does use Zookeeper. I think now the Yarn tracks its task in MapReduce. The task trackers are tracked by the using the Zookeeper. You can have a look at here. Okay, I was showing you, these are the, say Kafka is tracking its brokers using Zookeeper, and Storm is tracking all the nodes using Zookeeper, and HBase is tracking its region servers using Zookeeper. Okay, and there was some more. Hive server is using this one. Similarly, you could configure name node to track the secondary name node, primary name node using the Zookeeper. Okay, so the system uses the Zookeeper for many things. All right. Okay, then have a great day and see you on the next week. Bye bye. Yashwant's question is, what will be the developer has to do? Developer can use Zookeeper for synchronization between their own process. You can use synchronization. Say you are writing MapReduce and you want to, on every node, you want to load some config, or you want to avoid contradiction between multiple MapReduce. You can use that. Okay. And Zookeeper generally comes with the whole cluster. Okay, none of because even the basic service like name node and data node depend on Zookeeper. All right. So not really. In certain cases, when your MapReduce is say hitting the websites, you are writing a crawler in part of MapReduce, and you want to avoid certain connections. In those cases, you can use Zookeeper. The coordination between input file is sharded by Zookeeper, by MapReduce, but when you are using MapReduce, the input file is equally divided, is kind of divided by uh, by MapReduce, but the other coordination might require Zookeeper. All right. Sure. Let me go through the code and will share. All right. All right. Bye bye. Have a good day. See you next week. All right. So there are probably two more sessions. At most, there might be three sessions, but not more than that left. Okay. So 6 or 7 hours is what it will take more. All right. See you next weekend, and we will discuss Spark in greater details, and we will cover rest of the auxiliary components. Okay. We'll dedicate around 2 hours to Spark, which will be sufficient for you to learn. So we will talk about Spark next week. Bye bye. Bye Bishwa, bye Abhay, bye Mahesh, bye Midli, bye Prezi, bye Mamta, bye Yashwant.